Now let's look at the properties of parallel vectors. Two vectors are parallel if one is a scalar multiple of the other. This means that you can multiply one vector by some scalar number and it will become the other vector. This number is called the scalar k. In symbols, we write it as vector A is parallel to vector B if and only if vector A equal to k of vector B, where k is a scalar. Let's look at case 1 where they are parallel. If we have a vector A of column vector 2 over 4, and if we have vector B of column vector 1 over 2, we notice that if we multiply vector B by 2, we also will get 2 multiplied by column vector of 1 over 2 to get 2 over 4. So we can tell that column vector A is actually equal to 2 of column vector B. This means that vector A is a scalar multiple of vector B, and therefore we can conclude that vector A is parallel to vector B. If we draw vector A and vector B in the diagram, you can see that A and B are definitely parallel to each other. Now let's look at a case where the two vectors are parallel by opposite direction. If you have a vector C that is of the column vector -3 and -6, and if you have a column vector B that is of 1 over 2, you notice that vector C equal to -3 of vector B, meaning that vector C are parallel to vector B but they're in opposite direction. If we plot vector B and vector C on the graph, you could tell that B is 1/3 the length of vector C and is facing a different direction from vector C. And lastly, let's look at a case where two vectors are not parallel to each other. We have vector D equal to column vector of -2 over 1. We have vector B of a column vector of 1 over 2. These two vectors are not parallel to each other. You can see that you cannot have a scalar multiple of vector B to form vector D. If you plot these two vectors on the graph, you can see that these two vectors are not parallel. Let's learn about collinear points. Collinear simply means that three or more points lie on the same straight line. In other words, if you can take a ruler and you draw one single line that pass through all these 3 points, then the points are collinear. To use a mathematical form, we can say that point A, B, and C are collinear if the vectors from A to B and from A to C are parallel. That means vector AB equal to k of vector AC for some scalar k. This tells us that both vectors point in the same direction and they are just either stretched or shrunk version of each other. Let's look at the diagram on the right. Point A is at the origin. Point C is on the line between A and B. Vector AC and vector AB are in the same direction. This shows that you can travel from A to B and A to C along the same straight path, just of different lengths. So these points lie along the same line, they are collinear. In summary, whenever two vectors like AB and AC are parallel, the 3 points A, B, and C must be collinear.